Hi guys, so welcome back. And the next part that we're going to do for this lesson here, I am going to demonstrate to you how to do a neutralization calculation. So this is the first problem that I want you guys to do along with me. What volume of 2.0 molarity of sulfuric acid HSO4 is required to neutralize 200 milliliters of 0.50 molarity of sodium hydroxide NaOH? Okay. I like doing this on the annotator. All right, so let's do this one together. Okay. I like red. All right, so for this one, we are going to be using the equation, the normality of the acid times the volume of the acid also, equal to the normality of the base times the volume of the base. So let's take a look. What volume of 2.0 molarity HSSO4? That's sulfuric acid. So this is the acid. I want to note that this is the acid, and the other one, sodium hydroxide, that OH there gives you the clue that this is the base, and Arrhenius base. All right, so we also have the molarity here, okay? And remember, we're going to have to use the normality. We are still going to be using the molarity here to figure out the normality. So what we are going to do is to figure out how many moles of ions there are for each one. So for the first one, for acid, and we know that the acid is the sulfuric acid, H2SO4. That one will dissociate into the hydrogen ions and also the sulfate ions. So remember the crisscross method. There was a 2 down here where the H is, where the hydrogen is. Crisscross, so we know that is the oxidation state of the sulfate. All right, so going back to this compound here, we see that we have 2 hydrogens. So this 2 here tells you that we have 2 moles of ions, 2 moles of hydrogen ions. All right, so for the base, it would be the NaOH, sodium hydroxide. The hydroxide tells you it's a base. Dissociate that into the sodium ion and the hydroxide ion. Okay, we're going to pay attention to this part over here because that's the part that makes the solution basic. Okay, so we've got 1 sodium here, so we don't have to put a coefficient, and 1 group of this polyatomic hydroxide ion, so we don't have to put a coefficient here. So this one tells you that this has 1 mole of ion for this one. Now, what we're going to do, we're going to use the molarity for each one also. Okay, so for the acid, we'll take the molarity, which is 2.0 moles per liter times the number of moles of those ions. So it's going to be 2 over here for the hydrogen. And this will then give you 4.0 normality. So you're going to be using this for the normality of the acid. Okay. Now, let's try to figure out the normality of the base. Okay. Going back to this, now we're going to take the molarity of the base, which is 0.50 moles per liter, times how many moles are there of the hydroxide here? No coefficient. That tells you there's only 1 ion for every sodium hydroxide. Therefore, it is 1 for that one. And that gives you the answer of 0.50 normality for the base. Let's see, what else is there? We are looking for the volume of the acid. So that is your unknown. Yeah, because remember, whatever starts with what is, which is, what is the amount, that is your unknown. So we don't know what the volume of the acid is. That is what we are going to find out. But you are given the volume of the base here, 250 milliliters of NaOH of sodium hydroxide. So our duty is to neutralize this basic solution by adding acid. So we are given 250 milliliters. And remember, everything here is in liters, so you're going to have to convert this milliliters into liters. So follow along and see if this is review for you, if you remember how to do this. Convert the 250 milliliters, so it's going to be over 1. We always do that when we do our conversions. The conversion factor, and there are 1,000 milliliters for every 1 liter. Remember, we put the value with the same unit at the bottom here so that we can cancel that out. Remember, the same thing that is in the numerator and the denominator, we can cancel out because whatever divides itself is equal to 1. So your volume of the base is going to be 0.250 liters. And this is for your base. So going back to this equation here, we are looking for the volume of the acid. So you can always rewrite this equation so that it will just equal to the volume of the acid. And what you do here is you divide both sides by the normality of the acid. And then you just plug in all of your known values. So plug in the normality of the base, which is 0.50, capital N, times the volume of the base, which is 0.250 liters, divided by the normality of your acid, which happens to be 4. 4.0 normality. Cancel out the n's. Plug them into your calculator. Where's my calculator? Right here. If I can open it. All right. So it's going to be 0.50 times 0.250 divided by 4.0. And your answer will come out to be 0. And there's a lot of numbers here. We'll do our sig figs, 3125 liters. But you can always switch this back to milliliters. Okay, so let's turn this back into milliliters. We're just going to multiply by 1,000 or 31.25 milliliters. And let's take a look over here. 1, 2, 2 sig figs. 1, 2, 3, 3 sig figs, 2 sig figs. The least number of sig figs is 2. And this will be just plain 31 milliliters. Oops, milliliters. And that is how you figure out number 13, the first problem. Oh, is this not letting me? This is interesting. Oh, there you go. So that's how you do this problem. Now, can you do this next problem on your own? Remember, you are still going to use the molarity. You'll take into account the molarity and multiply that by the number of ions to find a normality of both acids and bases. So do this next one on your own. What volume in milliliters? So you're going to have to go back and forth. Convert them into liters and then convert back to milliliters. All right. So what volume in milliliters of a 0.997 molarity of potassium hydroxide, KOH, solution is needed to neutralize 30.0 milliliters of 0.0400 molarity of hydrochloric acid, HCl. Now, this next part here, you guys will learn how to calculate pH and pOH. And from what you guys remember, pH is measuring how acidic or basic a compound is. Okay, so it's to describe the strength of an acid or a base. So the pH scale will be from 1 through 14. Anything less than 7 is acidic. Anything more than 7 is basic. Around 7, neutral. Now, there is such a thing as pOH. It's just the opposite of pH, and we are more familiar with pH. But for chemistry's sake, we're going to have to learn the values of pOH. Just remember, it is the opposite of pH. It's also on a scale of 1 through 14, except less than 7 is very basic. More than 7 will be acidic. So it's just backwards. But again, we are very much more familiar with the pH scale. Okay, so for pH and pOH, just remember that the pH and the pOH in a solution must always total to 14. So we are going to use this equation also. For example, if you already know what the pH is, but you were asked what the pOH, you are just going to plug in the value of the pH. Okay? But if a problem gives you the value of the pOH, you're going to plug that in to find the pH. So it's a really simple equation here. Just remember this and know which values you are going to plug in. Okay? Now, what I want you guys to do is to go back and review the concepts of pH, compare and contrast pH and pOH, and try that neutralization problem. And I'll see you in the next lesson.